Talking of the harmonic wave functions are the functions which represent mathematically the periodic waves. The harmonic waves correspond to the periodic waves as the simple harmonic motion corresponds to the periodic motion. We know that to represent a simple harmonic or periodic motion, we use sine and cos functions of trigonometry, because sine and cos functions repeat themselves after a period of 2 pi. That is, after an angle of 360 degrees, sine and cos functions repeat themselves. So in order to show the periodic waves or simple harmonic waves, we represent them in form of sine or cosine functions. From previous lectures, we know that a periodic wave function is represented as y is a function of x comma t, that is equal to f of vt plus minus x. If we take y x comma t is function of vt minus x, this represents a periodic wave going from left to right. In order to represent a harmonic wave function, we have to replace this function by sine or cosine. But we know that here the argument is displacement, but the argument of sine or cos can be an angle only. So firstly we have to replace this function by sine or cos, and another important thing, the argument of that sine needs to be changed from vt minus x to angle. How can we change this displacement into an angle? We have to multiply it by 2 pi divided by lambda into vt minus x, and this argument is an angle, as we know that vt minus x is distance, lambda is distance, the distance cuts out and we get an angle. So in order to represent a harmonic wave function, y x comma t will be equal to r sine of 2 pi by lambda into vt minus x plus phi 0, or y x comma t is equal to r cos of 2 pi by lambda into vt minus x plus phi 0. Now what is the difference between sine and cos? Sine is used to represent those periodic waves which start from the mean position, and cos is used to represent the periodic waves starting from the extreme position, r being their amplitude, that is r being their maximum displacement. Here another thing is phi 0. This phi 0 is called as the initial phase or epoch. In order this harmonic wave function represents periodic waves, this should repeat after a wavelength interval of lambda, 2 lambda, 3 lambda or n lambda, or in the second scenario when we talk of time period, it should repeat itself after a time period of 1t, 2t or mt. So in order to show it is periodic or not, we have to replace this x by x plus lambda, and we have to replace, in the second scenario we have to replace the time t by t plus capital T, where t is the time period for one full cycle. Let's take the scenario first. So y x plus lambda comma t should be equal to or sine of 2 pi by lambda, multiplying it, vt minus 2 pi by lambda into x minus 2 pi by lambda into lambda plus phi 0. I have skipped a step here. Here x needs to be replaced by x plus lambda so as to see whether it is periodic or not. Multiply it by minus, it comes out 2 pi by lambda into x minus 2 pi by lambda into lambda. Now in this case lambda and lambda cuts out, so it equals r sine of 2 pi by lambda vt minus x minus 2 pi plus phi 0. Now from the study of trigonometry we know that sine of theta plus minus 2 pi is equal to sine of theta. So here it is equal to r sine of 2 pi by lambda into Vt minus x plus phi 0. Now look closely, it is the same equation here and here. That means we say that y x plus lambda comma t is equal to y x comma t. So it is periodic. That means after a span of lambda or one complete wavelength, the function repeats itself. That means it is periodic. Taking the second scenario of time period, that is one full cycle or capital T here. So y x comma t plus t is equal to r sine of 2 pi by lambda into v t plus t minus x plus phi 0. That is equal to r sine of, multiplying it, so 2 pi by lambda into Vt plus 2 pi by lambda into Vt minus 2 pi by lambda into x plus phi 0. Now here v is the velocity of the wave and t is time period for one full cycle. In one full cycle it traverses a distance of lambda. So here Vt is equal to lambda. That is equal to r sine of 2 pi by lambda Vt plus 2 pi by lambda into lambda minus 2 pi by x, 2 pi by lambda into x plus phi 0. Here lambda and lambda cuts out, 2 pi by lambda, taking 2 pi by lambda and 2 pi by lambda common, so it is equal to r sine of 2 pi by lambda into Vt minus x plus 2 pi plus phi 0. As already shown, sine of theta plus minus 2 pi is equal to sine of theta. So here it is equal to r sine of 2 pi by lambda into Vt minus x plus phi 0. Look closely, this function is equal to this and this is equal to yx of t. So here we can show that it is equal to yx comma t. Here it is equal to yx comma t plus t. That means after a time interval of one full cycle, that is capital T, the function is the same yx comma t. So it is a periodic function. Thank you.